All right, let's look at the homework 9.2, problem number 8. All right, so we're going to use the Euler's method with step size 0.5 to compute y1 through y4. All right, so I'm going to just pull out GeoGebra. All right, first I'm going to just define the right hand side of the differential equation. So I'm going to call it f of x comma y. And this is defined as y minus 2x, right? I'm going to hit enter. Right, and also step size is defined as 0.5, so I'm going to call h is equal to 0.5 and hit enter. All right, then we're going to have initial value would be, so x sub 0, so is equal to 1, right? And the y sub 0 is equal to 0, right? Because here initial value condition is y of 1, which is the x value, is equal to 0, which is a y value. So we put the 1 for x0 and a 0 for y0. All right, so Euler's method goes like this. So in order to find the x1 value, right, so all you have to do is take x0 value and add the step size to it. So that will be the x1, right? Then in order to find the y1 value, all you have to do is start with the y sub 0, then add, right? Then f of x0 comma y0. So you plug in the previous values into that function and then multiply by the step size. Then you get y1, right? So we can put y1 as -1 here, right? And let's find x2. So x2 is going to be take the previous one, which is x1, add the step size. So we got x2. And y2 is can be found by start with the y1, then you add f of x1 comma y1 times step size h. Then hit enter. So it's -3. So we have -3 there, right? And then we have x of 3 would be simply x2 plus h. So hit enter. All right, we got that. And y3 is going to be start with y2 plus f of x2 comma y2 times step size h. So we got the -13 over 2. So let's type it in. -13 over 2, right? And then just one more. x4 is going to be equal to x3 plus h. And y4 would be, all right, start with the y3 and plus f of x3 comma y3, then multiply by h. So we get -49 over 4. So I'm going to just type in that, -49 over 4. All right, let's double check. Submit for testing. All right, it came back and looks like we got all these guys correctly. All right, that's it. I hope that this was clear.